från alla medlemmar, partners och intressenter till ElectriCITY-TV som idag handlar om digitalisering och energi. Vi kommer tala om Helsingfors stad och deras spännande initiativ runt datadriven innovation och öppna data. Detta program ingår i en serie om våra verksamhetsområden smart energi, hållbara transporter, digitalisering och affärsmöjligheter i vårt MatchMaking initiativ. ElectriCITY har som mål att tillsammans med er från Näringsliv, Akademi, Offentliga, aktörer och Medborgare skapa en klimatneutral stadsdel här i Hammarby Sjöstad redan till år 2030. En modell för denna systemförändring ska gå till. En modell som kan replikeras både nationellt och internationellt. Dags att lämna över till min kollega och ElectriCITYs digitaliseringsguru, Rickard.
Tack så mycket. Och jag tänkte ju då säga att Sverige må vara bra på digitalisering, men tittar vi när det gäller öppna data och datadriven innovation så ligger vi långt efter. Och jämför vi oss till exempel med länder som Taiwan, Australien och Storbritannien så har vi långt kvar. Finland ligger på 5:e plats i Open Data Global Index där Sverige för övrigt ligger på 21:a plats. Och de har ett väl utvecklat koncept när det gäller öppna data och datadriven innovation. ElectriCITY har försökt dra sitt strå till stacken och startade i slutet av 2019 ett fastighetsdatalab tillsammans med RISE, Vasakronan och ett 90-tal andra bolag. Fastighetsdatalabbet har som syfte att samla fastighet- och energibranschen inom just datadriven innovation.
Idag så har vi med oss 4 personer med en bred erfarenhet av digitalisering och öppna data. Välkommen Kristoffer Sjöholm från Sweco med mångårig erfarenhet av öppna data, smarta städer och fastighetsdata som kommer vara moderator under presentationen idag. Vilken roll spelar stora offentliga aktörer som exempelvis Helsingfors stad vad det gäller öppna data inom energi- och fastighetsområdet?
Tack Jörgen, jättekul att få vara här. Jag tycker ju som öppen dataexpert att offentliga aktörer har en nyckelroll. Och det är väl just att mycket energidata och fastighetsdata är ju låst bakom privata bolag och även i viss publika bolag, i alla fall i Sverige. Och att städer som Helsingfors är beredda att öppna upp sin data så att det faktiskt går att göra smarta tillämpningar och AI-träna saker gör ju att vi kan göra våra byggnader helt enkelt smartare. Så att det saknas väldigt mycket bra data och att Helsingfors i det här fallet har tagit initiativ till det här tycker jag är jätteintressant. Och det ska bli väldigt intressant att höra våra 3 talare som kommer från Helsingfors. And now I will switch to English. And first out is Vera Savander. She's an energy expert at the city of Helsinki. And she will now explain why they are investing so hard in digitalization and open data. Please take over the presentation, Vera.
Thank you, Christoph. I'm Vera Savander. I'm working as a leading energy expert at the city of Helsinki. Our department is representing the owner of built assets, and that's why we are aiming to carry out our energy efficiency as well as carbon emission reduction targets related to buildings. And my topic here today is building-related open data, which is a part of our smart building concept that we believe is a one very important way to reach our ambitious carbon neutrality targets. So as a context, I would like to say that buildings really have a huge role in our carbon neutrality plan. As you can see, almost 100% of our CO2 emissions is generated by the energy consumption of buildings. When considering the Helsinki City Group and its operations. Helsinki is one of the pioneer cities in opening data globally. Actually, we want to open data if there is no reason to not open. Helsinki has launched a very ambitious digitalization program that will help the city to improve its services and renew operations in many ways. Helsinki is working closely with big cities such as New York and London to make the most of the opportunities provided by artificial intelligence, open data, and all kind of digital innovation. And by open data, we can make better decisions when the data reserves are harnessed for decision making. And we see that open data can be as a facilitator for new services and business opportunities as well, and support research and development activities as well. And open data also increases the citizens' understanding of their living area and then activates their participation. Open data also decreases the friction of using data, and I have heard that the value of open public data increases the more it's used. So in Helsinki, we have this Helsinki Region InfoShare, which is a open data web service for fast and easy access to open data sources between Helsinki and the neighboring cities. The data published there is mainly statistical, giving a comprehensive and diverse outlook on different urban phenomena like living and transport and economics and such things. And the data offer here is ready to be used freely with no cost. And there are also no limitations. Anyone interested in open data can participate. So we already have a lot of real-time data regarding our service buildings. The open API-based Nuka building platform has been used since 2019. And there are a lot of data regarding, for instance, energy consumption. There are hourly based energy consumption data of electricity, district heating, and district cooling as well. And then renewable energy production, of course. And then building basic info such as location, the purpose of use, and the area, and also coordinates. And then indoor air quality data is also available. Some buildings are equipped with sensors monitoring factors like CO2 levels or particulates or volatile organic compounds, and of course temperature and such things. And then also we have a building automation system data points connected to Nuka. And what is interesting as well is that we are having this user feedback data also at the system. Then it's possible to compare the actual hard monitored data like temperature and CO2 levels to the subjective feedback of the users of the school building, how they actually feel about the indoor air. So Olli Parkkonen from Nuka Solutions will tell you more about this Nuka system after my presentation. The threats and opportunities of opening the Nuka data content was examined at the end of the year 2019. And the main findings of the study you can see here in the slide. Those opportunities we already knew, but the biggest risk proved to be this subjective or wrong analysis and conclusions made on the basis of the data. But anyway, this study led to the decision to open the building basic data as well as the energy consumption data. And today we have this open data covering the main meter energy consumption data of approximately 600 service properties, meaning over 1,000 buildings. And there are these hourly based energy consumption data and the building basic data as well. And here you can see the link to the data, and when you have seen this data and have looked it, please come back to me with a new idea. You can provide us something unexpected so that we can cut down our emissions. Actually, we have some actual problems regarding the data validation. And then I would be very happy when I see an application for the citizens to somehow enlarge their knowledge and their role about the energy consumption. So this is what we have done, and actually Juha Yrjölä will present you a nice concept of utilizing the open data sources today as well. But so far, I would like to say thank you very much and have a nice day.
Thank you very much, Vera. And for information, we will have a short question and answers after the 3 presentations, but we will move on very soon. But it's very interesting to see your work in Helsinki. I think you're really a role builder, should call that, role model for what we should do in Sweden and Stockholm. And unfortunately, we're not doing so well, but maybe we can catch up. So anyway, now I would like to go over to Olli Parkkonen from Nuuka Solutions, and he will talk about the technical solutions that has enabled energy efficiency and good indoor climate in the Helsinki public buildings. Please take over the presentation, Olli.
Thank you very much, Christopher. Hello, everyone. On my behalf as well, pleasant to be presenting to you today. My name is Olli Parkkonen, and I work as a head of business development at Nuuka. And in my presentation today, I will tell you more about how our customers, especially City of Helsinki, can utilize our data platform in practice in order to make their assets more energy efficient, sustainable, and indoor climate friendly. To give you an idea how much data our platform analyzes in real time, so during this presentation, so basically during next 7 minutes, our platform collects and analyzes 9,000 energy consumption data points, 110,000 building process data points, and 35,000 indoor climate data points from different data sources in the buildings, all this in order to help our customers to efficiently manage their real estate assets. We offer a data platform solution for our end customers. So what we do is that we collect, we analyze, we refine the data from different data sources in the building and offer a different use case for different individuals within the real estate organization, ranging from the owners of the property to the actual building maintenance people who are doing the practical stuff. Today we have connected approximately 3,000 buildings to our software, and we have made about 100 ready-made integrations to different building automation systems, energy management systems, indoor sensoring systems, and so on. To mention names like ICA Real Estate, Unilever, the Edge Technologies, and the City of Helsinki trust our technology. And in the end, we make sense out of the data that we collect. We try to make it simple, relevant, actionable, especially for the business owner. The idea is that you can check, for example, the top 3 key performance indicators when you're going to your lunch and get the real-time picture of what is actually happening in your building portfolio. Then a few words about what we do with City of Helsinki. So today, over 1,000 buildings in the City of Helsinki area are connected to our system. And as part of carbon neutrality Helsinki 2035 program, we help them to make their city buildings more energy efficient and indoor climate friendly. And from City of Helsinki, energy and indoor experts are using our software for building energy reporting, indoor quality monitoring, and actually making sure that the buildings work as they should. And as Veera mentioned, we have also developed the open API for the City of Helsinki, enabling, for example, students or developers to access certain kind of data, namely energy consumption data from the platform. So open API can be used to develop other applications on top of the data that we already collect. In other words, innovate on top of the platform. Before the next presentation related to open API application from Juha, I will briefly present you a new concept that we are testing right now with City of Helsinki, and we are bringing that to the Swedish market as well. And it shows you what the data can be used to achieve better indoor air quality and energy efficiency in the buildings with artificial intelligence. So one concrete use case of Nuga data is our new AI Air concept, which is the first AI applications in the series that we are making. The basis for this new solution is that we believe that the artificial intelligence is the new user of buildings' HVAC processes. Nuga AI Air is an optimization application based on artificial intelligence and machine learning technology, which makes the operation of HVAC process more efficient. Nuga AI Air calculates the optimal air volume based on the HVAC process data that we collect, and then we send new set points to the building automation every 1 to 10 minutes. On top of this, clear key performance indicators in our dashboard makes it easy for our customers to actually see the energy efficiency savings in real time, see the indoor air conditions, and of course, show the economical impact of the optimized processes. And if I show you a concrete example based on the real data that we have now analyzed from the building. So on the left, you can see a blue line in a graph presenting current airflow in a specific area the air would optimize in this building. So basically, we can see that oftentimes there's a lot of partially unnecessary ventilation ongoing in the building. And by optimizing the building, so by predicting the CO2 values in the buildings, by using Nuga Air, our customers could make substantial savings in heating and electrical consumption. And obviously, all this is taking into account the good indoor air climate in the buildings, so that, for example, the ppm levels in the buildings do not rise too high. And based on our current implementations that we have done, we estimate that this can save up to 30% on electricity and up to 10% on heating in ventilation processes in the buildings. So basically, this would mean up to 100,000 crown savings a year in energy for a mid-sized school or office building. Thank you a lot for your time. Should you have any questions, please do not hesitate to contact me or my Swedish colleagues afterwards. And now handing back over to Christopher.
Thank you very much, Olli. Really interesting things you do. We have one more presentation before we have a panel discussing this. And the next presentation will be by Juha Yrjölä, I hope I pronounced that well, from Kausal. And he has developed 2 exciting climate-related applications using the open data provided by Helsinki City. Okay, Juha, take over the presentation.
Thank you, Christopher. And hello, everybody. My name is Juha, and I'm from a company called Kausal. And I'm very excited to have this opportunity to share the sort of things that we were able to do with this real-time building energy consumption data. So the question that we wanted to answer was what kind of new challenges we could solve using this hourly energy consumption data. We had the energy consumption data on about 1,000 buildings owned by the City of Helsinki, and that includes residential buildings, museums, libraries, so on, all kinds of buildings. And we wanted to focus especially on climate-related challenges, because that's what our company does. We build digital services to help cities reach their climate goals. So the first thing that we thought of was that perhaps we could generate a more accurate greenhouse gas emission profile for buildings. So, like, as we might know, traditionally the emissions for a building's energy consumption are typically calculated on the yearly level. So we have one number for emission factor, and then like we have one net energy consumption for the building. We multiply these two together and we get the building emissions. It's very nice and simple. But then we also know that the building's energy consumption can and does vary quite a lot depending on the season and the time of day. So usually in Finland, as probably in Sweden, most of the heating, most of the energy is consumed during the winter time, and most of the electricity in the daytime. And that's fine. That still wouldn't mess up the calculations. But the problems come because actually also the energy production emissions change quite heavily depending on the season and the time of day. So at least in Finland, in the winter time, we have to burn more fossil fuels to produce heat. So then the emission factor will be higher in the winter time. And then if we have a building that uses more energy in the summertime, most of the energy in the summertime, and less in the winter time, then if we calculate it on the annual numbers, then we would be overestimating the emissions, when actually they are quite a lot smaller. And this I would work the other way around. If we have a building that really uses a lot of energy in the winter time, then its actual emissions would be quite a lot higher. So what we did is that we built this tool that runs this hourly analysis. We generated this hourly emission factor, and then we used the hourly energy consumption data and run it over like all of the 1,000 buildings, and then we got a lot more accurate picture on what the true sources of emissions are. So then when we want to focus our mitigation resources, then we actually get to focus them more efficiently. And here is one result graph from the tool that we built. It shows the emissions over time, over 3 years, for this one building, School of Visual Arts. And this is not too surprising. Most of the emissions come from heating consumption, and it is the winter time that is the problem. So when we want to bring down the emissions for this building, this is where we should be focusing on. All right, so that was one of the tools. And then this other challenge that we wanted to tackle was related to solar panel installations, because we knew from the Carbon Neutral Helsinki program that the city needs to build hundreds and hundreds of gigawatt hours of rooftop solar power. But then the question is that where to start from? What would be the best buildings, the most cost-effective buildings to put solar panels on their roofs first, and what would be the optimal size of the solar power plant? And we know that the cost effectiveness of a solar plant on a rooftop depends on the electricity consumption profile of the building. There are many different kinds of profiles. If we have a building that uses most of its electricity basically when the sun shines, so in the summer and the daylight, then we get to use most of the solar panel production in the building to reduce the electricity that we need to buy from the national grid. So this one would be a very good fit, most likely. But then what about these other types of profiles? How would it be for them? And then again, what would be the optimal system size for each of these buildings? So we built a simulation model. We wanted to get a super accurate estimate of of the solar panel sizing. And what the simulation does is that it goes through all of the hours in a year. Here we have one winter hour, and then we have like a fairly small solar panel installation, and then the simulation basically calculates the energy balance for all of the hours. Here is 1 hour from the summertime, and we see that the solar panel is producing somewhat more, but we still end up buying electricity from the grid, and that is expensive. And then, yeah, we repeat the simulation for like all of the hours during the 3 years. And then we do the same thing with slightly larger solar panel installation. Here we see that in the summertime, we are already covering all of the building's own consumption and then producing a little bit more. And the rest we will be selling to the national grid. But selling to the national grid is not very cost effective. We get very little money from that. And yeah, then we try with even larger installation, and here we see that we're producing quite a lot more than we need. So probably this installation would not be very cost effective anymore. And when we put all of this together, this is one graph from our interactive tool. The green line shows the cost savings on a given panel size, and the red line shows the investment cost, like over 20 years. If the green line is above the red line, then it means that it is cost effective. We're saving money by installing this solar plant. And here we see like 20 to about 80 kilowatt peaks. That would be that would be good. That would be a good investment. We would be saving money. And if we look at the numbers, this is I think it's still the School of Visual Arts. And if we build a 60 kilowatt solar power plant there, we end up saving about 800 euros per year, which is not a lot. But then more importantly, we are reducing 2,600 kilos of greenhouse gases every year from the atmosphere. And then removing like each kilo from the atmosphere is actually like it costs negative euros. So we're removing greenhouse gas emissions and earning money while doing so. So it's kind of like a climate mitigation dream come true. And then here, finally, like is the list of the different open datasets that we used. There's quite a few, as you can see, and we would not have been able to make these tools without all of these open datasets. We're really grateful for all of these organizations who decided to open their datasets. And the tools that we built are actually fully open source as well, so you can freely use them if you want.
Thank you very much. We're running a bit out of time, so I don't think we will have so much time for questions, but I have a few to you. I would like to ask Vera first. What has been the main struggles for Helsinki to release this energy and real estate data as open data?
Actually, it has been quite smooth process because we already had this data collected to our NUCA system which is open API based system. So it was a very smooth process.
Do you have any cooperations with any cities or municipalities in Sweden? Or you mentioned New York. Couldn't Stockholm be a cooperation partner, for example?
Yeah, those were the cooperation partners of our digitalization program.
Okay, but you don't have any cooperation with the Swedish municipalities?
I must say that I'm not sure because we have such a big organization that I don't know if we still have some cooperation.
Probably somewhere in the organization someone has a cooperation, but not based on this. But how much actually usage of the open data do you have?
Yeah, we are using these Google Analytics to count the users, and Yesterday was 430 views following 6 weeks. So
yeah,
you got the number. Great. Yeah.
Thank you. Ollie from Nuka Solutions. What do you say? What is the hardest thing about connecting all these type of buildings you have in your system?
Yeah, that's a pretty good question actually, and I understand that's sort of a concern for many building owners. But our customers doesn't need to care about the process how we implement our software. So our experts take care of the onboarding process on behalf of the customer, and we are talking about a few weeks of time when we are actually getting all the data to Nuka and connecting different data sources in your building portfolio. And as mentioned, we have 100 existing integrations to building automation systems. So we have done that a lot before. And what comes to Sweden, for example, we work with Svenska Kraftnät. So getting data from there is no rocket science in that sense.
I was a little bit interested about the learning and improvement process in Nuka Air. How do you and in that case, how do you actually learn from the actual data you get in the AI process in Nuka Air?
Yeah, so as we implement AI Air service to a certain building, there is kind of a teaching period when we collect the data and teach the machine learning model to learn from that specific building processes in order to really optimize that specific building. So yes, there is a certain kind of, you can call it a teaching period. And after that, you can start using the actual model.
Yeah. And about climate and the Paris Agreement, for example, what can this kind of solutions have for impact for solving climate issues?
By using a solution like Nuka as part of the holistic plan to achieve emission reductions in a city level, cities can reduce the emissions of the buildings between 5 to 10% using this kind of solution. So
but I guess also all this data you have to manage, and you have servers and that. How do you actually count the usage? Because a lot of data is also a lot of energy about storing and managing.
Yeah, of course, there is a lot of actions that needs to be taken by city and the city experts by themselves when they are using a solution or building data platform like this is. But this makes it possible. You really need to have the data in one place, and you need to have all these analyses somewhere that you can actually make the actions.
Yeah. Okay, thanks. Very interesting, at least. I would say that you're doing a fantastic job. Yeah, and Juha from Kausal, I was really impressed by your optimization about the solar panels. Have you done any optimizations when you have like battery storage? You have more aspects of optimization than just solar panels.
Yeah, I'm really glad you asked, because I was considering it would be very nice to include this option in the simulation, because it does this hourly level simulation. We could easily try to see how it would affect things if we had like a certain size of battery. But currently, like, batteries are so expensive that probably it would not like bring any additional savings, but the prices of batteries are going down so rapidly. So I think soon it would be time to include battery storage in the simulation.
Yeah, and the last question, I would say that you said that producing a lot of solar exporting into the grid is not really that profitable. But in Sweden now we have a market, upcoming market for flexibility, that where real estate owners like Örebro Bostäder could actually be a part of energy flexibility. Is there such a market in Finland as well?
I'm not sure what initiatives are happening. I don't think there is like anything like this currently, currently implemented. But the thing is that you would need to store the energy somewhere. So if we have a lot of new solar panels, as we will, like in the upcoming 20 years, then in the like the summer months, in the daylight months, we need to store all of the excess electricity somewhere. But then, like perhaps we could use car batteries, electric vehicle car batteries, to store this energy. But the problem is that if we get like a surplus of electricity, we have to store it somewhere, and sometimes even the price of electricity will go negative. So you have to pay money in order to feed your electricity into the grid. So this is a bit of a challenge, but we need more storage options, and then we can realize this.
Yeah, but it's really good and interesting market, and I've been working a little bit for a company called Power to You in Sweden that's doing this solutions here, so it's very interesting. Thank you very much, and we have gone over time, so now I will hand over to Rickard and Jörgen to finish this up. Tack så mycket.
Tack Kristoffer och Rickard och alla våra experter i Helsingfors för er medverkan idag och de innovationer och möjligheter ni har berättat om. Och nästa tisdag så kommer vi tala om mobilitet. Hur vi kan göra det lättare att hitta laddare, boka laddare och betala för att ladda elbilen. Ta hand om er tills dess. Hej då!